Hi, my name is Arif Shami and I would like to present alloy and its importance, which is a subtopic for 8.1. Definition of alloy is a mixture of two or more elements where the main element is metal. There's a lot of objects made up from alloy in our daily life. Example of alloy is aeroplane made of duralumin, bronze is used to make a medal, brass is used to make key, steel used to make body of a car, pewter used to make souvenir, and stainless steel is used to make cutlery. Comparison between alloy and pure metal. Surface. Alloy has a shiny surface while pure metal have a dull surface. Resistant to corrosions. Alloy resistant to corrosion while pure metal are easily corroded. Hardness. Alloy is hard while pure metal is less hard. Pure metal are ductile. Pure metal atoms are in orderly arrangement. Therefore, when force is applied, it will be easier for the atom to slide over each other. Pure metal are also malleable. There are empty spaces in pure metal atoms. Therefore, when force is applied, it will fill the empty spaces. Arrangement of alloy is formed when foreign atoms are mixed with pure metal. The foreign atom will disturb the orderly arrangement of atom of pure metal. Therefore, it will be hard for the atom to slide over each other or to fill the empty spaces, which is made arrangement of alloy are not ductile or malleable. And now, let's take a look at composition, properties, and uses of alloy. First alloy is duralumin. Composition is 93% of aluminium, 3% of copper and magnesium, 1% of manganese. Properties: stronger than pure aluminium, low density, and does not rust. Uses: body of aeroplanes, electric cables, and racing bicycles. Second, bronze, made of 90% of copper and 1% of tin. Stronger than pure copper, does not rust, and shiny. Uses: medals, monuments, and trophies. Brass, 70% of copper, 30% of zinc. Stronger than pure copper, does not rust, and shiny. Uses: musical instrument, doorknob, and keys. Steel, 98% of iron, 0.2 to 2% of carbon. Also known as carbon steel, stronger and harder, malleable, and there are three types of steel, which is low carbon steel, average carbon steel, and high carbon steel. Uses: structure of building, railway tracks, and body of a car. Stainless steel, 73% of iron, 80% of chromium, 8% of nickel, 1% of carbon. Stronger than pure iron, resistant to corrosion. Uses: cutlery, sinks, and surgical instrument. Lastly, pewter, 95% of tin, 3.5% of antimony, 1.5% of copper. Stronger than pure tin, does not rust, and uses is decorative instrument, trophies, and more. So that's all from me. Thank you for listening.
Hi everyone, my name is Felicia Emrina binti Ihwani and my topic for today is 8.2 composition of glass and its uses. So glass has its main component which is silica or silicon dioxide, and its main characteristic is brittle, chemically inert, hard, transparent, heat insulator, does not conduct electricity, and not permeable to gas and liquid. Next, type of glass and its properties. So first, fused silica glass. The property is high melting point and does not expand or contract easily. The next one is soda lime glass. The properties is low melting point, easily shaped, cannot withstand high temperature. And second last is borosilicate glass. High melting point, expand and contracts very little when there is temperature change, can withstand high temperature and chemical reaction. And the last one is like glass. The property is high refractive index, high density, and shiny. So next is the type of glass and its example. So fused silica glass. The example is lens of telescope. Second is soda lime glass. The example is glass container. And the second last is borosilicate glass. The example is laboratory glassware, and the last one is like glass with its prism. So the composition is first pure silica glass. The composition is silica, and second one is soda lime glass. The composition is silica, sodium carbonate, calcium carbonate. The second last is borosilicate glass. The composition is silica, sodium carbonate, calcium carbonate, boron oxide, aluminium oxide. And the last one is lead glass. The composition is silica, sodium carbonate, lead to oxide. Thank you. That is all from me. Bye.
Right, next to me, 8.3 composition of ceramics and its uses. Okay, what is ceramic? Ceramic is basically solid made up of inorganic and non-metallic substances. How does to produce the ceramic? Production of ceramic involve the process of shaping and hardening using heating technique at high temperature. Most of ceramics is made up of metal, non-metal and metallite compounds. Next, these are the three examples of ceramic product, which is aluminium oxide, titanium carbide and silicon carbide. These are 6 basic properties of ceramics that we have to remember. The first one is it is high thermal resistant, break easily, chemically inert, electrical insulator, hard and strong and heat insulator. Next, why ceramic are high in thermal resistant and hard and strong? It is because ceramic are bonded together by strong covalent and ionic bonds. Why ceramic cannot slide over each other? Because the atoms of ceramic are strongly bonded in indefinite arrangement. Why ceramic are brittle and weak towards stretching? This is because the energy from the force will be used to break the bonds between the atoms. And lastly, why ceramic can conduct electricity or heat? This is because electrons in ceramic cannot move freely. Alright, next, types of ceramic. The first type of ceramics is traditional ceramics. The traditional ceramics are made from clay such as kaolin. The step to make it is clay is mixed with the water to produce soft moldable mixture, and the mixture is heated at very high temperature to produce a traditional ceramics. The examples of traditional ceramics are pottery, bowl and bricks. Next, we go to the advanced ceramic. The advanced ceramic is made up of from inorganic compounds such as oxides, carbides, and nitrites. It have higher resistance to heat and abrasion, more chemically inert, and have superconductivity properties. The example of silicon carbide is it is used to make a cutting disc due to its hard and strong properties. Next, it also used to make brake discs because it can withstand thermal shock and hard resistant to heat. Lastly, advanced ceramic also used to make tungsten carbide ring because it is hard and resistant to abrasion. Alright, these are the list of ceramic uses application. For the medicine, zirconia ceramic is used in dental implants, alumina ceramics is used to make a knee bone, and ceramics is also used for magnetic resonance imaging or MRI machine because it has superconductivity properties. Next, for the transportation, components of engine in jet planes are made from ceramics, and the last one is energy production. Ceramics is used to make electrical insulators in high voltage areas such as power station. Okay, that's all from me. Thank you.
Next, we move to our last subtopic for this chapter, which is composite material. material. A composite material is a material that made from combining two or more non-homogeneous substances, which is matrix substances that mix up with strengthening substance. Both components of composite material have different physical and chemical properties. When they combine together, the composite material form has better properties than the original components. Next, we move to uses of composite materials that are widely used in development and advancements of technology nowadays. For number one is reinforced concrete. It produced when steel bar or wire mesh, which is a strengthening substance, is immersed in concrete matrix substance. So reinforced is widely used in the construction of bridges, dams, and buildings. Number two, we have fiberglass that produced when plastic, which is a matrix substance, is strengthened with glass fiber, strengthening substance. So this composite material is used to make helmets, car bumpers, and printed circuit boards. Number three is optical fiber. So the innermost layer is the core that is made up of silica glass fibers, which is the strengthening substance. The core is encased in the second layer or cladding that is made up of glass or plastic matrix substance. The outermost layer is made up of plastic that acts as a protective jacket, which is matrix substance. So for example, we have a video camera, cables in computer network, and optical fiber. Photochromic glass. It's formed when glass matrix substance is combined with silver chloride and copper 1 chloride, strengthening substance. When exposed to sunlight, photochromic glass darkens. This is due to the formation of silver atoms that prevents the passage of light. In dim light, copper 1 chloride in photochromic glass catalyzes the reverse process so that glass becomes transparent again. The last one is superconductors. White germanium copper oxide, which is YBCO ceramic, is a composite material that has superconductivity properties other than alloys. This superconductor is used to make electromagnets that are superconductor magnets or supermagnets. Superconductor magnets are light and have strong magnetic force. It is used in magnetic resonance imaging MRI, nuclear magnetic resonance NMR, and particle accelerator. Let's see their comparison and differences in properties of composite materials and their original components. The difference of reinforced concrete with original components. So the concrete, the properties is high compression strength, low stretching strength, and resistant to corrosion. The steel bars or wire mesh has high stretching strength and corrodes easily. When they combine together, it produces reinforced concrete that has high compression strength, high stretching strength, and resistant to corrosion. Fiberglass. The properties in plastic is low stretching strength, low heat and electrical conductivity, resistant to corrosion, and durable. For glass fiber, the properties is high stretching strength and low heat and electrical conductivity. So the fiberglass has high stretching strength, heat and electrical insulator, and resistant to corrosion and durable. For optical fiber, the properties for the plastic is high compression strength and flexible. For the glass fiber, it has a low compression strength and hard. So it produces optical fiber that has high compression strength and flexible. For photochromic glass, the glass is transparent and does not absorb UV rays and not sensitive to light. For silver chloride, it's transparent to visible light, absorbs UV rays, and sensitive to light intensity. So the photochromic glass is transparent, absorbs UV rays. The absorption of UV rays depends on light intensity. The last one is superconductor. So yttrium tricarbonate plus copper 2 carbonate plus barium carbonate and oxygen. So these elements have a high electrical resistance at room temperature. So superconductor, which is YBCO, doesn't have a electrical resistance at very low temperature.